Good morning, class. In the previous term, we were discussing allotropes of phosphorus. There are three allotropes of phosphorus we discussed in our previous lecture. These are the white phosphorus, red phosphorus, and black phosphorus. White phosphorus is white waxy translucent solid which is insoluble in water but soluble in carbon disulfide. It glow in dark, also react with NaOH. It should be noted white phosphorus is less stable due to angular strain in their molecule. Red phosphorus is iron grey luster, non-toxic, insoluble in water as well as in CS2, doesn't glow in dark and occur in polymeric form. Black phosphorus has two forms, alpha black and beta black. Now let us discuss phosphine. Student, phosphine is colorless gas with rotten fish smell. It is prepared by the reaction of calcium phosphide with HCl or water. When calcium phosphide having formula Ca3P2 react with HCl, we will obtain 3CaCl2 along with phosphine. Phosphine has a rotten fish smell. Calcium phosphide when react with water, we also obtain phosphine along with slackline, that is CaOH whole twice. So these are the two methods by which we prepare phosphine. It should be noted phosphine has pyramidal shape. Phosphine has a pyramidal shape and it is basic in nature because it reacts with acid to form salt. PS3 when react with HBr to form salt, show that it is basic in nature because it reacts with acid to form salt. PS3 is colorless gas with rotten fish smell and highly toxic. PS3 is basic in nature because it reacts with acid to form salt. Now the question arises, what happens when white phosphorus react with NaOH? Student, white phosphorus when react with NaOH in presence of water to form phosphine gas along with sodium hypophosphite. White phosphorus react with NaOH to form phosphine gas along with sodium hypophosphite having formula NaH2PO2. Now, it should be noted the spontaneous combustion of phosphine is used in Holby signal and in smoke screen. Now, the question arises, which has more bond angle, pH4 single positive or pH3? To solve this problem, now let us draw the structure of pH4 single positive and pH3. When we draw the structure of both of the compound, we will obtain this type of structure. It is the pH4 single positive and this is for pH3. In pH4 single positive, phosphorus atom is sp3 hybridized, while in pH3 phosphorus atom is sp2 hybridized. Therefore, the bond angle in pH4 single positive is more as compared to pH3. Now, let us discuss phosphorus halides. In phosphorus halide, we deal with two types of phosphorus chlorides. These are, the number one is phosphorus trichloride. Phosphorus trichloride has a formula PCl3 and it is prepared by passing chlorine over white phosphorus. When white phosphorus react with chlorine, we will obtain PCl3. PCl3 has pyramidal shape. PCl3 has pyramidal shape with lone pair of electron on phosphorus atom which make it basic in nature. Phosphorus basic in nature. PCl3 is a colorless oily liquid. PCl3 is a colorless oily liquid. The second type of halide of phosphorus is Phosphorus Pentachloride, which has a formula PCl5. It is prepared by the reaction of phosphorus with excess of chlorine. Phosphorus when react with excess of chlorine, we will obtain PCl5. PCl5 is yellowish white powder which on heating decompose to give PCl3 along with chlorine gas. It has trigonal bipyramidal structure. PCl5 has trigonal bipyramidal structure in which phosphorus atom is sp3d hybridized. The correct structure of PCl5 is drawn on board. The two vertical bonds are said to be the axial bonds. These has a bond length approx 240 picometer, while these three bonds are the equatorial bonds, which have bond length 202 picometers. It should be noted that all PCl bond in PCl5 are not equivalent. There are two axial bond in which the bond length is 240 picometer, while the three equatorial bond is there in which bond length is 202 picometer. Now, let us question arise. Why does PCl3 fumes in moisture? One question is given in NCERT. Why does PCl3 fumes in moisture? Student, PCl3 fumes in moisture because it hydrolyzes in presence of moisture to give white fumes of HCl. And the reaction is PCl3 when react with water. PCl3 when react with water gives white fumes of HCl. It gives white fumes of HCl, due to which that is why PCl3 fumes in moisture. Now balance the equation. Okay. Now the next question is, what is the basicity of H3PO3? H3PO3 has a basicity 2 because it has two ionizable hydrogen atom. Now let us discuss the oxoacids of phosphorus. In oxoacids of phosphorus, now let us draw the structure of oxoacids of phosphorus. The first oxoacids of phosphorus is number first is hypophosphorus acid having formula H3PO2 and the structure is H3PO2. It's a hypophosphorus acid, formula H3PO2. The second one is orthophosphoric acid. Orthophosphorus acid. It has a formula H3PO3 and the structure is this one. The third one is the orthophosphoric acid. Third one is orthophosphoric acid, formula H3PO4 and the structure is it has three ionizable H positive ion, but this one has two ionizable H positive ion, so it show basicity 2 and it show basicity 3. Now the fourth one is pyrophosphoric acid. Pyrophosphoric acid has formula H4P2O7 and has a structure P single bond O like this manner. H4. It's a pyrophosphoric acid, formula H4P2O7. The next one is the cyclotrimetaphosphoric acid. The fifth one is cyclotrimetaphosporic acid, formula HPO3 whole thrice, and the structure of cyclotrimetaphosporic acid is represent like this manner. The structure of cyclotrimetaphosporic acid is there. So these are the some also acids of phosphorus. I discuss once again. Hypophosphorus acid, formula H3PO2. It has one ionizable H positive ion, so its basicity is 1. Second one is orthophosphorus acid, formula H3PO3. It has two ionizable H positive ions, so its basicity is 2. Third one is orthophosphoric acid, H3PO4. It has three ionizable H positive ions, so its basicity is 3. Fourth one is the pyrophosphoric acid, H4P2O7. तो फिफ्थ वन इज द cyclotrimetaphosporic acid, HPO3 का whole thrice. So these are the some oxo acids of phosphorus.